Can grade 5 students come up with math conjectures? Indeed, yes, they can. And your child also can. Welcome to Math Inquiry Based Learning Journey session by the Gym Foundation. This is Vidya Govindan. I'm going to share some interesting activities that I recently had with grade 5 students in the fractions concept, which promoted a kind of asking questions environment and then making them more curious, find patterns and make observations and enjoy the process of learning. So, in this process of learning, they also came up with conjectures, which is nothing but an educated guess based on their observations, and then which led to kind of prove them or disprove them with counterexamples. I'm going to share that activity and the framework we used and the approach we taken to all of you for you to kind of be part of this learning journey and make your own observations, conjectures, and go ahead with proving them. So, usually, fraction concepts are taken by sharing some examples of this kind of a pizza or a roti or a chocolate bar diagram and ask them to understand how these are equal parts divided and good going. And when the concepts are being explored further, they are just taught that there are these kind of fractions like fractions, unlike fractions, what is special about like and how to compare. So basically, children are mostly taught that when the like fractions are there, you just need to compare the numerator and figure out which is bigger. And for example, for unlike fractions, they may be taught just find the LCM of the denominator and then make into like fractions and then figure out which is bigger or smaller. However, with these kind of teaching and learning, one of the important aspect that is missing is, are the children understanding why some things work that way? And most importantly, are the children coming up with expanding their knowledge base by asking questions why something works that way or finding patterns through different fractions? Those kind of learning will essentially make them more interested towards what they learn. And that is the power of inquiry based learning, where children are kind of provided an environment and framework to ask more questions to figure out through a discussion and debate why some things work that way. So we are going to see a few activities now in a preparation phase where children are given this framework of over technique like observe, verify, examine, and reflect. So with this technique, the children can provide a framework to go through this process of observation, verifying, and then reflecting, asking some wonder questions. So this is the first part of this episode, and then the second part will actually lead you to the actual conjecture they come up with. So follow this preparation phase, and then go to the conjecture phase to figure out your own observations. So first, we can start with the like fractions with this activity, where the teacher has given every student a kind of a mat which is divided into 16 equal parts, and then asking them to color it the mat so that they are having some designs. And this is the colors that they have. And finally, the teacher was asking who has done more of the red color, which mat is having more red color. And then they were telling, yeah, it is Deepak and Ramya, because Deepak has colored around 8 of the total 16, and Ramya has colored around 8 of total 16. So both of them have done more color. And this is how they are able to understand that when the parts are equal, then they can compare just the number of parts. So children are now given the activity and they are made to think, what do I need to find? How many red color parts is been colored more in which mat? Then how do I already apply the knowledge of fraction? Basically figuring out that the total number of equal parts is 16, and Ramya and Deepak both have colored 8 parts with red. So here, when they wanted to compare 8 by 16 and here with the 5 by 16 and then 4 by 16, when they are asked about questioning, how do you compare? How did you say Ramya and Deepak had got more? Because they actually had the red parts. So this is how, when you have the like fractions, which is having the denominator same number of equal parts in one whole, you can actually compare the numerator. So as part of this like fractions, we also took some examples to conclude actually same for many things. And as part of the reflection where we actually ask about the wonder questions. Children came up with very interesting wonder questions. Compare like fractions which are improper fractions using the same approach. Can we compare like fractions which are mixed fractions using the same approach? And when the children are asked to give examples for that, they gave wonderful examples. Like, for example, if I want to compare 29 by 4 and 6 by 4, or 3 by 4, how do I compare? Can I just compare the numerator? Will it work? And then children understood, yeah, so this is just 29 by 4, which means you have as many equal parts, which accounts to 29 entire parts selected, right? So obviously this can be more. They understood it from pictorial and from the number perspective. Again, mixed like fractions, so they came up with very interesting example. Okay, ma'am, so if I have 3 2 by 7 and 3 5 by 7, so, well, can I just compare this improper, like the proper fraction in the mixed one? And they actually did with some examples that assume that I have three whole, yeah, and then the fourth whole is actually having 2 by 7. So in the fourth whole, I divide into 7 equal parts, and then I'm selecting only 2. And in the second case, the 3 remains the same, but just the 5 by 7 alone matters, where in one whole, around the 7 equal parts, I am just selecting the 5. So they understood that in the mixed fraction, it is enough to compare the proper fraction alone. So in this case, it will be 5 by 7 will be greater. And another boy came up with an example. Oh, then here the whole numbers are same. But what happens if the whole numbers are different? 5 2 by 7 and 3 5 by 7, and immediately the answer came up. Oh, there are 5 in this first fraction and only 3 in the second fraction, so we don't need to do any fraction comparison, it's just normally bigger. So this kind of I reiterates how the same approach can be applied for different fractions, the questions coming from the children's side. And next we actually had another interesting approach, and this time with the unit fractions. So in this activity, children are given a metered length thread and then asked to kind of cut into different equal parts. Each of them can decide whether I cut with 9 equal parts or 7, 3 or 10, any number of equal parts, and then they're just given to use only one part out of whatever they have cut for their craft activity. And then the question was asked, which one of them is biggest or the longest, yeah? And then they figured out, oh yeah, I think Prabhu is going to have a more, because the entire 1 meter thread he just cut into 3 equal parts, right? So each part is very long than what I have cut. For example, if I have cut with 5 equal parts, it would look like something like this. So obviously mine will be smaller. So they understood as part of this technique, which is like a reinforcement of what they already know about fractions from comparing like fractions and what fractions mean. They understood that this unit fractions is about comparing the denominator. So for example, if I say 1 by 9 and 1 by 3 and 1 by 5, and they could see it visually and they could understand that 1 by 3 is the greatest fraction value, which is the longest. And they also kind of made different kind of experiments and figured out that it is true. They figured out by comparing different fractions, unit fractions, with one as the numerator and different denominator. And after actually making these kind of execution and verifying, they again did the reflection part of asking what kind of wonder questions you may have. Anything crazy would be good. And then they come up with really good observation, man, that when I compare these fractions, right? So, like for example, 1 by 9, 1 by 3, and 1 by 5, I could see that bigger the denominator, as the denominator gets bigger, the value gets smaller, because the actual size of one part is also getting smaller. And they gave a very interesting example of the pizza. I have a pizza, and if I divide into half or the quarter, and I'm taking only 1 by 4, then I'll have a bigger piece. And if my friend is just dividing the pizza into half, then she'll be having bigger than me. But if my another friend is going to have a pizza with 1 by 8, then obviously she'll get a smaller piece. So then they all understood that 1 by 2 is really greater than 1 by 4, which is greater than 1 by 8, obviously, in this case. And then came another interesting question. Will this approach work only for unit fraction, ma'am? Or the speciality of unit fraction is all those have the numerator being 1. Will the same be applicable for a different numerator value, but that is same across all the fractions? And then when encouraged to give some examples, they gave, okay ma'am, instead of having 1 by 3, if I have 2 by 3, 2 by 5 and 2 by 9, will still 2 by 3 be greater? Can I tell that? And then they came up with very interesting numbers that they can try with. And one child have told that this will hold always true. And when asked, clearly explained that, okay, let's take the pizza example itself. And then we'll have half, we'll have quarter, and we'll have 1/8 of it. So if I have 1 by 2, that is fine. I can't have both, then it will be one whole. But if I have two parts, 2 by 4, or two parts of this 8, or two parts of the 16, then obviously, then if the number of one equal part is greater, then obviously the two of them would be really greater than two of the 8 equal parts. So these are the small kind of approaches and conjectures that made them come up with a good pattern identification, which resulted in making their knowledge base widen. This is just a small kind of an activity which triggered their curiosity and coming up with different questions. So ask questions based on these activity, and then share it in the comments on what kind of observations you can make and which results into an educated guess, which is nothing but a conjecture. Stay tuned for the second episode, which has a very interesting conjecture that will help you compare fractions easily. Stay tuned and thank you.